Okay, so if any of you don't know who the Concrete Centre are, this is our website, produced lots of great guidance, involved with the industry sustainability strategy, 10 years anniversary of measuring and reporting and setting and meeting brilliant targets to do with all aspects of sustainability, but also lots of guidance about what you can do to get the best out of concrete. And as I said, come along and have a look at the exhibition over there of some of the stuff that I'm going to talk about now. So, if we're going to talk about innovation, it would be completely remiss of me not to start with a bit about digital fabrication. It's what is most exciting about the time that we're in at the moment. It's just been described by Timothy Wangler there at the brilliant ETH Zurich, so the university over there, as the third industrial revolution, changing the way that we do things, not just from a data point of view, but from the technology and how that's impacting on how we make stuff. And that is really, for me, a lot of this is about the complete new aesthetic that it's starting to create as well, let alone the way in which we can actually make. So 3D printing, you may have seen, there's lots of examples that have been, you see mesmerizing YouTube videos. So this is concrete that's being poured robotically or automatically, but like a tube of toothpaste on top of each other. It can either be done in situ or on site, and it's layers and layers of concrete that gets built up. Now, early adopters were people like Professor Krasnevis down in California, contour crafting. He was predicting that we're going to be able to print our cities by machines rolling down, printing a house in 24 hours. Chinese have been doing some precast. Loughborough University, brilliant early innovators. But now what's starting to happen? We've got a house that's been built in the Philippines, tornado resilient house. The Russians have built a house. They're saying they've got the first one with a contour with an arm that swings around. It can be immobilized on site in half an hour. And of course then in the French and the Germans are building in Dubai. And Dubai have said, I don't know if you've seen, they plan that by 2030, 25% of all their properties are going to be printed. Wow, so they're doing it. Starting to feel like a space race, isn't it? The Chinese have printed a bridge, beautiful, gorgeous. I've got so many slides I want to show, and I haven't got time because it's only 20 minutes. I talked about the space race. Yes, they're now also thinking about 3D printing on the moon. Because of course aggregates don't travel. You're going to make concrete in the UK, you're going to be using UK aggregates. In the moon, you wouldn't take them. You're not going to take them to another country. You're certainly not going to take them to another planet. So it's using moon dust and moon rocks to 3D print extraterrestrially. Oh, amazing. If you want to know more about it, we've got a great article in one of the publications over there. So is it 3D printing? Is that the future? Is this, this is certainly innovative concrete in terms of its development, but actually maybe it's also this, slip form dynamic casting. So slip form we're all very aware of, but actually using a robot to do it and twist and move it around. Or is it actually 3D printing the formwork? So actually making the thing that we can cast into, like Smart Slab here, where you can create the most thin, this is a fibre reinforced and post-tension slab there, but talk about material efficiency, amazing, and the look of it. You think, well, it's a bit futuristic. Are we going to do that? Well, we're doing it. Crossrail, the crossrail panels that are for the lining are cast against 3D printed formwork, but 3D printed formwork in wax, so it can be recycled and used again. Oh, I'm so excited. And they're really strokeable as well, don't they? And I think the making of 3D formwork, I think, is really exciting because straight away that's not necessarily getting involved with some of the challenges to do with anything to do with infrastructure and innovation of something really important like concrete. Whether it's a recyclable formwork or permanent formwork, where you actually make and 3D print it and then pour the concrete inside it, so the two act structurally together, that immediately can be doable within current standards because the structure is what's holding it up, and we know how to do that. Or 3D print the insulation as formwork. This was done in Nantes as part of the Digital Week a couple of years ago. It's not quite as refined, pretty gloopy, but it's 3D printing. Where's this going to take us? But of course, if we're going to be doing all these efficiencies and the technologies in the concrete, we need to think about the reinforcement. So we've got a lovely piece of this knitted reinforcement on the stand over there. So this is digitally made. This is John Orr at Cambridge University looking at placing the reinforcement where it needs to be. So if our concrete is all starting to become amorphic and 3D designs, so actually our steelwork needs to not be rigid and flat as well. So there's opportunities of innovation within there. Now, using and making complex shapes within the making of formwork isn't actually new. It's very well established within the industry. Within this, it's often to do with 3D scans. Have you seen this one of the Elgin marbles? This is built as part of the Olympic Village. So this is precast concrete cladding that's poured into a mold that was created from a digital scan of the actual Parthenon frieze that's in the British Museum. It's all about starting to, and this is exactly the same with in situ. So it's the same process that's created these ornate details there for this pigmented concrete that's in North London. So the idea of actually being able to create complex geometries to pour the concrete into, but then use them again and again, is what's getting me quite excited, because it's about building in beauty and interest. And there's a lot of discussion about off-site and its repetition and what's that going to do to our built environment. But actually, the potential there is, unparalleled, because with formwork, that's where most of the cost is. So if we can just do it once and reuse it, brilliant. That's what we should be doing. But a lot of the innovation that's associated with concrete isn't all quite so obvious. There's an enormous amount of it going on in the mix itself, stuff that you can't necessarily see. Okay, and so that's research to do with new forms of concrete. Concrete's been evolving since it existed, in accordance to cost or what materials are available, and that's not going to stop. That's going to keep evolving, and we're starting to do more stuff. So whether it's the use of admixtures to change the performance of the concrete in its liquid or its hardened state, make it stronger, use less water, make it flow, or lightweight or insulating concrete. Now these are all here. These aren't research and in the future. These are all available and part of the tools that we should be using. The industry have been innovating. So this is innovation of using alternative fuels. I think I saw the figure there that the concrete industry uses 210 times more waste than it produces. That's the latest figure, because we've been measuring this stuff for 10 years and reporting it. A lot of it is to do with this clima fuel, or using waste as a fuel to make the energy to make the cement. That's brilliant. There's some clima fuel over on the stand as well if you want to have a look. Thanks to David over there. So the use of waste to make the energy in the manufacturing is one of the parts of it. The use of low carbon cements, some of these also byproducts of other industries, help lower the carbon footprint of concrete even further. And again, this is all available. This is stuff that you could do. Some of these make the concrete actually more durable. They're available. Why wouldn't we do it? So we've got lots of good guidance about using that. So that's ground granulated blast furnace slag, so GGBS, because that's too long a word to keep saying every time. Fly ash and limestone increasingly. And things are changing. So there's a new amendment to the British Standard, which is allowing it and making it easier to use limestone powders as a cement, so cementitious. And that's brand new. That's just coming through. So the industry is looking and evolving and changing and improving the way it does things all the time, as you would hope and expect. But it's not stopping there. New generations of cements are bubbling away, coming through. So we're carrots. Have you heard about this? There was some of this in the press. They're literally using waste root vegetables, getting the sort of nanoplatelets, and don't ask me what that is because I don't know, but using part of that to help create a new type of cement that is apparently stronger. So research going into that. Graphene, you'll have heard about that, making stronger, more durable, water resistant. There's a whole new generation of cements called alkali activated cementitious materials. Now these ones are slightly further up the food chain, if you like, or down, whichever. There's already a PAS standard for these. So we've got things like an AACM using GGBS. So there's no cement in there, but there's a type of cement, but it's using GGBS as its pozzolan, or a geopolymer based on calcinine clays. So these are being manufactured already, and for certain uses, these are starting to come through. There's a PAS standard that's enabling us to build for low-risk applications at the moment, I would generally say, because it's you've still got to go through the testing, but it's there. This is all happening and will be happening more and more in the future. I'm convinced of it. It's not going to stop there though. Carbon sequestering concrete, so concrete that actually even absorbs it, whether it's from a precast, used in the precast industry as a cement that needs not water but carbon dioxide to cure, so it goes hard through the process of absorbing carbon dioxide. Or this innovative lightweight aggregate that has become lightweight by being blown up. Normally it's air that sort of makes Rice Krispies. I think it's not Rice Krispies, but this is using carbon dioxide. So that's what's making it light. Again, sequestering it. And this stuff is based on waste. So this is being used for block work. But the use of waste in material or recycled content, again, isn't new. Maybe we're doing a bit more of it than we have done with recognition, but the use of secondary aggregates, recycled crushed concrete aggregate, these are all possible to use in concrete. Now, not in every type of concrete, as you'd expect. There are different grades of concrete. Concrete isn't a thing, it's lots of different recipes. So you use, according to the recipe, you use what particular type of concrete that you're after. But what else? I mean, what's going to be the future of what we go into concrete? Is it going to be shredded tyres? Sheffield University are doing research of looking at all the different parts of a tyre and what that could do in concrete. Plastic bottles, there's research in Bath and Cambridge where they're looking at crushing that to create a sand. Now, in the UK, we don't have a shortage of sand for concrete, but in other parts of the world, maybe they do. So this might be a solution, maybe in somewhere like India, that they could start looking into. There is an enormous amount of innovation and research happening. And it's going to take a while, a lot of this to start to bubble through to the surface, but who knows? What's that next one going to be? Eggshells? I don't know. I mean, what? So other research and other innovation that's starting to come through. So this is ultra high performance concrete. So this is changing what we would normally expect of concrete, which is big, fat, solid structures. This stuff is ultra thin, ultra strong, actually a bit more like steel in the way that it acts than concrete, but it doesn't rust and it's going to be self-colored and it can stay there for a lot longer. So you can do things with it that you wouldn't normally do. Now this is a building, this is in the south of France, and most people I think that it's a metal brise-soleil over the whole building. It's not, it's concrete. Concrete canvas. This is just add water. This is concrete that comes in a roll. Being used a lot for stabilization of soils, usually in other parts of the world actually, or creating very fast, quick, fresh water ducts. Just roll that out, add some water, and you've created a culvert. Brilliant. So that innovation has completely changed the way that we're using these types of material. I mean, it's sort of barely concrete, if you like, but it's still a cementitious-based material. But then there's concrete that can actually enable us to reduce flood risk. So water permeable concrete, or concrete that glows in the dark because it's got aggregates that are charged up during the day. We've got examples of all this over there. Light transmitting concrete, concrete that lets light through it, that's still structural. Concrete that can encourage growth of vegetation on it. So, that's immediately obvious what that might do as a benefit for all of us. Maybe it's to do with the changing the local environment around a building, but also via biodiversity. But different innovative surfaces, casting photographs in the face of the concrete, blending with other materials, using the concrete to reduce pollution, to eat smog. So this is a product. But there's actually a whole church built of this stuff in Rome in precast concrete, where it reacts with sunlight from the noxes and the soxes in the environment. And because it reacts and takes it out, it means it doesn't get dirty, so it's self-cleaning. And in fact, this product itself, this photocatalytic concrete is the technical term for it, actually uses 80% recycled aggregate as well, because in Italy they're lucky enough to have Carrara marble as a waste aggregate, so brilliant. So they can get this beautiful white concrete. But it's not the only way that uses are coming through. So we're looking at concrete as an energy store. There's amazing towers that stack themselves up in the same principle as hydroelectricity. So when they've got a lot of energy, they stack themselves up, and when we need it again, the concrete blocks get dropped gently to the ground. Amazing stuff. Look at that. Look at concrete as a smart battery, where actually it can be used. You could have the infrastructure could start to be the capacitor to help even out the energy loads that we have from the renewable energies that are coming through. So lampposts that could actually be solar charged, so that during the day they charge up, and at night they use their own energy stored in the concrete to light up. So the use of technology and integrating that within concrete goes right the way through, whether it's from measuring the curing to being able to, and doing that on site, or whether it's about predicting what the age of the building is and what's the health check of our building. There's a brilliant new geopolymer that's come through. We've got a sample where it actually has a charge in itself, so it can work out from it being a smart material, what the health of the concrete is in itself. So going forward, that's what we're all going to need to know about. We've all got to get smart. Data is going to be embedded on our buildings, whether it's as it is now through the use of barcodes, or whether it's actually e-tagging. So we actually embed the data, we know what's been built, where it is, so that we can reuse it again, or we know at what point it needs to be reused, ideally, hopefully around for a lot longer. Loads of technology going on within the world of precast, as you'd expect, off-site. We've got smart bending machines, we've got parametric modeling, use of magnets. We've got obviously BIM design. I mean, it sort of goes without saying that that's part of innovation. And we're going to hear a lot more about this from Simon later on. But it's not just in precast, it's within ready-mix. So you've got concrete that's being monitored within its truck, and then it can adapt itself by adding the admixtures. You don't even need to put a slump test in, you know, or you've got so it's not within the manufacturer, it's also about providing a data and a customer platform so that the logistics is smoothed out, so that we're able to get rid of paper in the whole process. And there's so much more, and I'm already running out of time. There's so much that we could be talking about, whether it's all the innovative precast housing solutions that are starting to get dusted off or being used now to try and help meet the housing crisis, or whether it's the use of low energy logistics and low energy delivery of lorries and electric quarry material. Oh, I'm just going to keep going on. So there's lots. Hopefully, you're going to want to find out much more about it. If you do, please, by all means, get hold of me. I'm just skimming the surface. I'm not an expert in any of these by any means. I'm just sort of collecting them, inspiring with them, and hopefully trying to share so that you can understand what's happening and we know where things are going in the future.